What's up YouTube? TCM here, back with another video, and today we're going to be doing a longer video teaching one of my favorite programming languages, which is Rust. So full disclosure, a lot of this course comes from the Rust 101 course over on TCM Security Academy. We're going to be covering the first 2 hours or so of a 5-hour course. You're going to get through all these fun topics here. I'm just going to scroll through them, but we're going to cover a lot of content all the way through this challenge B. If you're interested in learning more, this is the only time we're going to pitch you. You're welcome to check out the TCM Security Academy. You can get access to this course and other programming courses and hacking and all their fun stuff, but we'll cover more information, control flow, functions, more challenges, all kinds of more fun stuff. So you get the first 2 hours. It's a really good chunk of this course. Also gives you a good sample for Rust. Hey, why buy a course if you're not actually interested in Rust programming? So hopefully this gets you interested in Rust. It's a great programming language. Hopefully you'll become a Rustation after this and you learn something from the next 2 hours we are together. So we're going to stop here, take a quick ad from our sponsor, and then we're going to jump right into this course on Rust. Man, why does it always feel like I'm playing catch up with security? Are you having trouble with your code again? Yeah, I can't seem to keep up with all the vulnerabilities. I can write all this code, but fixing it, man, it's like running a marathon with a weight strapped to my ankle. Man, I used to feel the same way until I started using Sneak, but it does all the heavy lifting for you. Let me show you. So first things first, you got to go to sneak.co/thecybermentor. And then you just scroll down right here and you can get started with GitHub, Google, or even Bitbucket, Azure ID, Docker ID, and so much more. Once you're signed up, you can come in here and add a project. I'm going to select a project from GitHub. And once your project's imported, Sneak finds your vulnerabilities and you can fix them with just a click. Watch this. Come into here, I can open a fix PR or a pull request, and Sneak opens fix PR so you can merge and move on. Plus it does it all from your existing tools, IDEs, CLI, repos, pipelines, Docker Hub, and more. And look how easy that was to just do a pull request with these issues in hand. It's amazingly fast. So what are you waiting for? Come check out Sneak and find out if there's any vulnerabilities within your project. It's free, and you can sign up using my link at sneak.co/thecybermentor. Welcome to this Rust 101 course. My name is Heath Adams and I will be your instructor for the entirety of this course. A really quick who am I? I am the CEO at TCM Security. We are a dual-headed organization that offers training and consulting services. If you're watching this course, it's most likely that you are on the training side of the business. On the consulting side, my background is in ethical hacking. We provide ethical hacking and penetration testing services, as well as other consulting and cybersecurity services. On the training side, we've got a lot of different courses. We started out teaching ethical hacking, but have branched out into blue team, forensics, defensive side. We've branched into Linux and Python and other coding courses, and this fits right in with the rest of it. So if you're unfamiliar with Rust, we'll cover that in just a second. If you're interested in finding out more about me or connecting with me, you're welcome to connect with me on LinkedIn, Twitter. Welcome to follow on YouTube and Twitch as well, as we do live stream, and we do have content on YouTube and over 500,000 subscribers at the time of this video. So we'd love for you to subscribe and help get us to 1 million. The sites below that you see, you'll also see our tcm-sec.com website. That is our website for consulting. The Academy is the website you're on right now, and the certification site is for our certifications such as the PMPT, the PCRP, PGMR, etc. Moving on, let's talk about Rust. And by the way, I hate PowerPoints. This is the only time in this course you're ever going to see a PowerPoint is for the introduction. Outside of this, it is completely hands-on. I absolutely hate doing slides. So really quick, what is Rust? Well, Rust is a systems programming language. We can think of it as similar to C++ or maybe even Haskell. And that's mostly because it's been influenced by those languages. Rust has its own syntax and features which make it really awesome. Some even compare Rust to coding languages like Go and Swift because it has focus on performance and safety, which is really nice. And you can see it's designed to have low-level control over a system. All right, so we are focused on a lot of things with Rust and has a lot of improvements. In fact, Rust was created by Mozilla, who makes the Firefox browser, and Rust was utilized to create a new version of Firefox, which became incredibly fast and efficient, and that was because of Rust being used. It was actually really cool. The big benefits of Rust are memory safety. That's really number one in my opinion, and that's why it's listed first, because it has an ownership and borrowing system, which we'll talk about in the course, and it helps prevent a lot of common mistakes that developers make. All right, so it helps make the code more secure. It's also a very performance-based programming language, which is awesome. It has concurrency, which is really neat. And also the community for Rust is fantastic. You're going to see that there's documentation out there. There are books written that are open source. It is fantastic to find resources and information on Rust, along with a lot of tools that are built out there. This is a very quote unquote up and coming language because it's newer, but it is so awesome. And it just does a lot of things that you wish you could do with some of the other languages. Ultimately, the expressiveness helps us be more concise. It allows us to be more secure, allows us to avoid bugs. And that is what really sets Rust apart, in my opinion. You can do a lot of cool things with Rust, and we're going to see some of that functionality in this course. And with that, what are the requirements for this course? Well, all you really need is patience and willingness to learn. If you've never done coding course before or learned any coding languages before, that's perfectly acceptable. This is a 101 course. You're expected to know nothing, honestly. And you just need a computing environment other than that. We need you to be on Windows, Linux, Mac, whatever's fine. And you should have 8 gigs of RAM. If you have less than 8 gigs, it's okay. Just ideal to have 8 gigs and 20 gigs of disk space. Again, ideal to have 20 gigs. Don't really need it. We're not going to create any large projects in this course. With that out of the way, let's talk about what we will cover in this course. And to do that, it's probably just best to kind of scroll through the curriculum as is right now. So we are going to talk about how to install Rust. We'll talk about creating projects, hello world, and comments and error handling, all those things. We'll talk about the different primitives. If none of this makes sense, by the way, don't worry about it. At the end of each section, by the way, there's going to be section quizzes in here, so that way you can have a test on knowledge. Everything in these videos is going to be hands-on, coding, direct as well. We'll cover variables. We'll have different challenges along the way. It'll get a little bit more advanced as we go. So I'm not going to list out every single topic. You're welcome to look at the curriculum as well, but you'll see that we have different challenges as we go. And then eventually we build into the very end, which is going to be tying it all together. And we have some projects that are in here. One is listed as coming soon right now. I do plan to add more to this course. I think in its current form, it's very, very complete, but I always am looking to add more fun items and projects, things like that. So at the time of this video, we only have 3 projects, but you may see more by the time you purchase this course and when this is recorded. And for every item, if we just go and click on a random item, let's look at something like math operators here. If we click on this, and you'll see what the course format looks like. You'll have a video in here, and with the video underneath, you'll have instructions or additional learning material and reading material in here as well. So just depending on the video that you're on, there may be more detail or less detail. Like for example, if we look at strings, looks like there's some detail in here. It gives you more information than just what you see in the video. That way you're having different forms of learning from both video-based learning and written-based learning as well, along with the quizzes that come with each section. So the overall goal by the end of this is that you take this and you have a foundational knowledge for Rust. You have all these items that you learn, then you start to build out projects, and you have challenges where you're forced to kind of do it on your own and see if you can put things together based on what you learn. And my goal for you by the time you walk away from this is that you have a very strong foundation that if you wanted to build upon this and go out and be a full-time Rust programmer, you absolutely could. And that's really it. I won't keep you much longer for this video. I don't like really long introductions or anything like that. I know you're probably anxious to get started. So let's just go ahead and get started. Again, all you need is a machine and a desire and willingness to learn. Let's go jump into the next video where we talk about course support, and then we'll get this ball rolling and start working with Rust. So I'll see you over in the next video. Before we dive into the course, I want to make our Discord server known and available to you. And this is a very, very important resource. Okay, at the time of this recording, we've got 51,500 people in here. And this is the place that you would go if you have any questions about your course. Now we have 24/7 support. You can identify our team and staff here in the right-hand side. You can see staff, admin, and support. Again, we're available 24/7. First stop when you get here, please read the server rules. So if you come into server, make sure you read the rules, understand different items, understand about pinging people and things like that, and just make sure you read through that so you're an upstanding citizen. Once you're through that, you can scroll down and you can come to this Start Here Academy section. In this Start Here Academy section, there will be a placeholder for the Rust 101 course. It's a placeholder now. There will be an upside down smiley face here. All you have to do is click the upside down smiley face to join the private server. All these servers that you see right here where it says Academy Private, these are course channels that you can join if you're a part of the course. And what that gives you access to, we'll look at an example real quick. Here's the PAH course, which just launched a couple weeks ago. And you can see people are in here talking about the course, about the materials, asking any questions. They can come in here and make suggestions about the course, any items, anything like that. This is a great place to not only ask questions if you're having trouble, but to also network with other people going through the course with you, find additional resources, etc., etc. Now, on top of this, we also have a ton of other channels in here. We've got channels to just chat with people, so off topic, InfoSec discussion, but we also have channels down towards the bottom where you can talk about different foundational skills. If you're in this programming course, you can talk about programming. We have different sections of InfoSec that you can chat through. We've got different lab areas, career. We've got resume help as an example, job postings in here, certification discussion, even pet pictures and random stuff like that as well. We do put on some occasional live streams and make announcements in here that are important. So it's very worthwhile joining. This is the only place that we offer support for our courses. If you email in, we're going to redirect you to the Discord channel because we can offer support in real time and live screen with you, share screen if we need to, etc., etc. So I will link the links to the Discord in the description below. I'll also show them to you very quickly. So it might be a little hard to read, but discord.gg/TCM will take you there, as will tcm-sec.com/Discord. Same place, all right? So you just log in, come in here, you can continue on, join, etc. All right, very, very easy, very straightforward to join. And that's really it. So again, if you want course support, this is the place to go. Make sure you're tracking. Otherwise, let's go ahead and jump into getting started with this course. Let's talk about installing Rust. Now, installing Rust is fairly straightforward. If you are on Windows, Mac, or Linux, very easy. What you do is you go to the rust-lang.org website, and I'm going to put all the links in the description below, by the way. So just check that out if you need them. But then you just go to install here. And under install, it'll have Rust up here. So you can have Rust up for Windows 32-bit or 64-bit. Or if you are a Windows, Mac, or Windows subsystem for Linux user, you can use this curl command right here to install Rust. Now, if you are a Windows user, let's go ahead and follow along. If you're a Linux user, go ahead and get this installed, and then we're going to follow along as well. So for Windows, you can use rustup.rs and just go ahead and download this executable. You will then just run the executable and follow the on-screen instructions. It's really straightforward, so straightforward I don't even have to show you. Literally just click next, 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 all right? Get them installed. The other thing you're gonna need as a Windows user is this Microsoft C++ build tools. Now go ahead and download that, install that as well. Once you have all this installed, Windows, Linux, Mac, whatever, you're going to need an IDE, all right? And I prefer Visual Studio Code. This is very, very easy to work with, and this is what we're gonna use through the course. So I highly recommend using this. If you have a preferred IDE, if you have something you're familiar with already, you wanna use it, that's fine. However, Visual Studio Code is my go-to. On this website, code.visualstudio.com/download, you are going to need to download your respective installer. So if you're on Windows, download the Windows installer, Linux, etc. All right. Once you get that installed, everything installed in your computer, you need to reboot. So again, if you are on Windows, you need the Rust up, the C++, Visual Studio Code. If you're on Linux or Mac, go ahead and just grab this curl command, run that, then go ahead and download Visual Studio Code. All right, reboot after that, and then come back and meet me here because we have a little bit to do within Visual Studio Code. Okay, so when you get to Visual Studio Code, it may look a little bit different than what you're seeing on my screen. That's okay. What you want to do is find this extensions button over here on the left. All right, and you want to search for Rust Analyzer. I've already got it installed on my machine, but just search for Rust Analyzer. You'll come over here and you'll just hit the install button for it, all right? That will give you Rust Analyzer. That's going to allow you to analyze your Rust code in real time and identify bugs and flaws as you go, which is really, really awesome. And you're gonna see it throughout the entirety of the course. So by now you should have Rust installed. You should be able to run Visual Studio Code. You should be able to install Rust Analyzer, have that installed, and then you should be able to meet me in the next video where we talk about actually utilizing Rust, creating our first project, and running through everything. So let's go ahead and stop here and do a quick video on documentation. Then we'll meet in the next video after that, and we'll talk through setting up Rust for your first project. So let's go ahead and meet in the next video. Now that we've installed Rust, I briefly wanted to show you the documentation that is out there for Rust. And there are two really, really good resources, both provided by Rust itself. So the first one is a book called The Rust Programming Language. This is free to use, open source, and you can come in here and look at various areas. So like installing Rust, hello world, all the way down to variables, functions. You scroll down, it just gets more in depth as it goes. All right, so there's tons and tons of information here about Rust. And if you ever have a question, you're ever unsure, you can Google it. You can use the Rust book. It's absolutely awesome. Another example of this is Rust by Example. So it has an introduction, but it starts out with hello world. And all this shows you the code and everything within it. It explains a lot of things in detail, and it's broken down really well. I think I actually might like this a little bit better than the Rust Programming Language book, but both are fantastic resources. I found myself when I first got started going through back and forth, reading various areas to get a deeper understanding because maybe one resource is not the best. Same with a course, right? Like this course, you may say, hey, I want to learn more about X, Y, or Z. Go out and read the documentation. Go out and try to have a deeper understanding of what you're seeing, especially if you're confused by anything. So I just want to point out that they're out there. I'm going to link these in the description below this video so that you have these resources available to you. Please utilize them as you need. So that is it. Let's go ahead and get started with Rust. Okay, let's create our first project in Rust. Now you can do this in one of two ways. You can use a terminal or command line, or you can actually use Visual Studio Code. If you're running Visual Studio Code, you can just go to terminal and do new terminal. And what we're going to do here is we're going to run what is called cargo. So we can type in cargo, and we could type in new, and then we can give this a name. We could just say my Rust project. And then we can hit enter. Now, what is cargo before we do anything else? Cargo is the Rust package manager. It's also a build system amongst other things. So it is what we're going to use to create our projects. If you're ever familiar with pip in Python or npm, it's very similar and does a lot of things for us. So here we're going to use cargo to create our project. We could also use cargo to build and compile our project, and we'll see the different cargo features as we go. So we just created a new project, and now we need to open this. So what we can do is we can go to File and then Open Folder. And you can't see it on my screen, but it's going to open up a window for you to allow to select a folder. All you got to do is select the folder called My Rust Project or whatever you called it and hit Open. And that will bring you to this screen here where now you can see your project. So within the project, we have a few things here. We have this main project here, or the source where we have the main.rs. We also have a toml file and a lock file. You can see other things being generated currently. This toml file is very important. So this TOML file is what has all of our configuration information in it. So you can see we have the name of our project. This is what's here. We have the version of our project. We've got the edition of Rust that we're running right now, which is 2021. And any dependencies that are in here. So we don't have any dependencies right now. We'll talk about importing libraries later and adding dependencies. So you don't have to worry about right now, but this file is where we add any dependencies to our configuration. This will eventually get added to this lock file. You're not supposed to be editing this, as it says, do not edit. This just stores all of your dependencies for you in this lock file. So your TOML file is very important. Your other important file here is going to be your main.rs. And if we want to run this, there's a couple ways we can run our first program before we get into what the program does or any of the other stuff. We can hit run up here if we have installed the Rust tool that we went through, the Rust analyzer here, right? Or we can actually do it from the terminal as well. So if you take a look, we can see that it says, hey, hello world. It printed that out. That's great. And we can just hit any key to close this out. We can open a new terminal. We can actually do this from cargo as well. So what we can type in is cargo run, and then that will run this. And you can see it says hello world as well. So I like to just run it from up here. Anytime I want to run, just hit run and it runs the project for us. Very easy. So that is it for this video. Let's go ahead and pause here and I'll meet you over in the next one. Okay, so you had an opportunity to look at our program in the last video. And all this program does currently is it just prints out hello world. Very standard for any program that you run, any coding language. Typically, your first thing you write is hello world. What's nice about this project is it's already built in for us. So what we have here and what we're going to start with is just breaking this down before we go any further. We have a function here, or what's called fun, and a function is a piece of code that we're going to get into in just a little bit, all right? I like to think of them as mini programs. We'll have a whole section on functions coming up. This function is main. Main is our main function. It's exactly what it is. And this is where our program begins, essentially. That's how I like to think of main. Okay, and within our function, we have this macro here. And if you see me hovering, by the way, that is just to show you that you can hover over some of these things like a function or this print line, and your code will tell you, or your IDE or Visual Studio Code will tell you what this is depending on the program that you're using. Here you can see that this is a macro. I like to think of a macro as just a built-in function. It's also a program of itself. So what we're doing here is we're running a macro called println or println exclamation. And we know it's a macro because of the exclamation point here at the end. And then all we're saying is here's a string. So a string here where it says hello world. And I just want you to print out that string. Okay, easy enough. We run it and it says hello world. Great. Now, if you're familiar with programming languages, such as Python, you could run a print command as well. And we can just say print and do hello world again, for example. And in here, you'll see that if we save this, Control S, or go up to File Save, and run it, it will run. If we take it one more time, let's take a look at what we're actually doing. And just save this one more time and run it. Okay, there is no break line in here. There's no new line that's occurring. What's nice about println compared to just print, and why println is used mainly, is because it automatically gives you that return character or that new line character. It's automatically built into this macro, this little function. So I'm going to go ahead and delete this here. But that's the main difference here. So what are we doing in this program? We're taking main, our main function, and we're telling it to do something. So that do something is run a macro, println, to print out hello world. That's pretty much it. Save it, run it one more time. And there we are, we're back to hello world. Let's briefly talk about comments here. So we have our main program and we can add some comments to it. And this is what's going to make us a better programmer. So we can come in here, and comments within Rust are done with 2 forward slashes. It turns green. You can see that we are writing a comment, and we can just say this is a comment. Now, why are comments important? Why do we care here? Well, what happens if you're a developer and you're writing this out and tomorrow, unfortunately, you get hit by a bus and nobody knows how to read your code because you didn't put any comments in there? That would be an unfortunate event. You should be very detailed and documented what you're doing. Not just if you're working internally at an organization. If you're going to go put code on GitHub, it's very nice of you to be able to put comments in, not just for yourself, but for other people, again, that could come in and read your code and understand your logic and what you're thinking. So you can put things in along the way. Now, there are many different ways to comment. This is an example here. We can actually comment right on the same line. We can come in here and just say, this prints hello world, if you wanted to. So you could put whatever you want within this comment here. Another thing that we can do is actually make these comments multi-line. Now you could do it like this, for example. You can come in here and say, this is a comment, adding a second line. You can even add a third line and continue on. But there's an easier way to do this. We can come in here and say something like a forward slash and then add an asterisk here. And then you see it automatically created a comment for us here. It created the ending of this asterisk. So this is what a comment block looks like. So in here we can put, this is a comment, and then you can have it extend multiple lines, and it extends multiple lines automatically, something like that. And as long as it's within this forward slash asterisk and then the asterisk and the forward slash here again, anything within here is a comment. It's not going to be read by code. You can prove that and actually save it. And then just run this really quick. You can see all that prints out is hello world. Nothing else is read here, just our main function. And these are just for ourselves and our sanity and for other people as well. So make sure that you write comments as you go, especially when you're studying. It doesn't hurt to put notes in here for yourself as you build out your programs. So something to consider, and we'll be using this along the way as well. So that's it for this video. I'll go ahead and see you over in the next one. Okay, so this is right where we left off. I'm just going to clean this up a little bit, and I quickly want to demonstrate errors to you. So what is nice about having our terminal here, and when we run this, we can actually see some of the errors that happen. So let's say that we're familiar with a different coding language, such as Python, as an example. In Python, we can come in here and we can print lines or use a print statement, right? And we can come in here and instead of putting quotes, we can do quotes like for hello world, but we could also do like hello world. And you can see this is already throwing an error for us. It's yelling at us, and you can see it lighting up because we can't use single quotes for a string like we could in Python, not in Rust at least. So if we come in here and we save this and then we try to run this, we're gonna get an error. What's nice about this is the error will automatically tell you where it's at here. Your compiler will fail, and you can see the error code that's here, and it says, hey, undetermined character literal. We're trying to run a character here, which is done in single quotes, and it's seeing that, but a character is only one item. And we'll get into characters in a little bit, but we can't run a whole string in place of a character. So what's occurring here is an error. It's expecting one thing, we're giving it the other. And it's telling us what it's expecting. If we're ever confused, we can actually run this rustc command explain, and it will tell us. We can copy and paste this into a terminal, and it'll tell us exactly what's going wrong here. So for example, if we come in and we just paste this back and hit enter, it'll tell you, hey, a character literal wasn't ended with a quote. And it shows you an example of an error, what that looks like. So here it starts, but doesn't finish with that single quote. And to fix this error, add the missing quote. Okay, well, we did that. So this isn't incredibly helpful, but it should give you some indication you can actually look a little bit further, because this is a character. Again, the more we learn, the more we'll figure out, but we can only put one character in here, such as that. That makes it okay. So let's go ahead and save here. I just wanted to show you that there are error outputs in the terminal. You should be using that to debug as well. and that will make your life a lot better. We're going to have a lot of people, and I see it all the time, where people come and they say, my code's broken. And the first question I will ask you is, did you read the output? And this is true for a lot of languages, not just Rust. So make sure you're reading the output, make sure you're Googling what you're seeing if you're confused at all. And your IDE is your friend here. So make sure you're utilizing this and what it's telling you when you're actually coding out as well. So that's it for this video. We'll go ahead and see you over in the next one. Let's briefly talk about primitives. So primitives can be a few different things. We have what are known as scalar types. So we just say scalar types in here, and these notes are for you as well. So we can have an integer or an int, we can have a float, we can have Boolean expressions, and we can have characters of the char. Okay, and first things first, what we're going to talk about are integers. So you could think of an integer as like the number 1 or 100 or 1,000. Those are all integers. And these could be represented in a couple of different ways. We have unsigned, like in type, and we have signed, okay? And the way that I like to think about this is unsigned means never negative, where signed means can be negative and positive. So there would be situations where you might want to use one or the other. Typically, we use signed as a default. Even in Rust, if you don't declare, which you'll see declarations here in a little bit, if you don't declare, it's going to automatically default to what is known as I32. We'll talk about that here in just a second. But there are different types for unsigned and signed. We have U8, U16, U32, U64, U128, and usize. And just like that for the unsigned, we have the same thing for signs. We have I8, I16, I32, I64, and I128, along with isize. So what do these mean? Well, if we break it down, the U is unsigned, quite obviously, and the I is for a signed integer. And we have these numbers afterwards, 8, 16, 32, 64, etc. Well, this is the number of bits. So the higher in bits that you go up, the more data that it can hold. And we can take a look at that here in just a second. But the standard, again, is this I32. And most system architectures nowadays are running on 64-bit. If you wanted to run 64-bit, you could. However, I32 is actually faster even on 64-bit architecture. So this defaults to I32. You have to keep in mind what size you want to run depending on the architecture that you're running. If you're running something with like a 16-bit processor, you're not going to want to run a U128 or an I128, for example. And lastly, we have this U size and this I size. The way I like to think about this is the number of bytes that it's going to take to reference any location in memory. And if you're not familiar with C, that's okay. But what you need to know is, say we have a 32-bit target and we say, okay, well, I want to know the U size and the I size. Well, on a 32-bit target, it's going to be 4 bytes. If we're on a 64-bit target, it's going to be 8 bytes, and so forth. We'll make declarations as we go, and we'll explain things as we go, so don't be overwhelmed at this point. But let's quickly take a look at these sizes that we have here, and we're just going to pick a couple out. So if we wanted to say something like print line, and we wanted to come in here and declare something like, let's just say max size of a U32, we can come in here and do that, and we can say something like brackets like this, do a comma, and then we can come in here and just do U32 max. Like this, all right? And then what this is doing is we have a string here. The string is just saying max size of a U32, and we put these brackets here. This is a placeholder. The placeholder that we're holding for is this right here, and we're saying, hey, U32, this is an unsigned integer type. It's exactly what it's telling us. And max is saying, I'm going to take the max value that can be represented by this integer type. Cool, easy enough. Let's save that and just run this really quick. And you can see here is the max size of a U32. Okay, well, what happens if we take that up to 64, for example? Let me just copy this. And we'll paste this and we'll just make it a U64. And we'll run it one more time. You can see that this number is going to be significantly larger. Okay, so look at the number and the difference between 32 bits and 64 bits. We could do the same thing. I'm just going to copy both lines and we can look at the i's here. So if we just replace the U with an I in both of these and just see if there's any differences here. Run this. And you can see there are some differences here as well. All right, so keep that in mind. The differences again between unsigned and signed integers. We know unsigned can never be negative, while signed can be negative and positive. Now we'll take a look at the other scalar types. We just covered ints. And something to note really quick, we're not going to touch on it right now, but there are what is called literal integers. So we can call them, or integer literals, int literals, whatever you want to call it here. And these are a kind of literal for a value that is directly represented in source code. So for example, we could have decimals, right? Like if I could type decimals, like we've seen, like 1000. We could have like binary code, such as binaries. We could say like 11110000, something like that, and so forth. So we've got those. We'll cover those as we go. Nothing to worry about right now, but just know that integers can be decimals, like be binary, hex, octal. We can even have a byte as well. So I'm going to go ahead and delete this, but I just wanted to cover that really briefly. For now, we just want to know that we have unsigned and signed integers, and they can vary in size depending on the architecture that you're running. And the default that you should know is I32. Let's go ahead and stop here, and we'll move on to the next thing, which will be floats. So I'll see you over in the next video. Okay, let's go ahead and talk about floats. I'm just continuing on right from the last video. We come in here and we can just say floats. Now, floats only have two types. We've got F32 and F64. And if you said, hey, that's for bit architecture, you would be absolutely correct. Okay, and we call these bits of precision as well. So F32 has 32 bits of precision, where F64 has 64 bits of precision. 64 bits is actually the default, or F64 is the default, just like I32 is your default. Here, F64 is the default. However, it can be slower on less than 64-bit architecture. So if you know you're developing something for 32-bit architecture, perhaps F32 might still be the way to go. All right, so with that in mind, we can do something similar here. I guess we should define what a float is before I just throw information at you. Okay, so if an integer is something like 1,000, a float is something like 1,000.1. Okay, it's this 0.1 that we're after here. Now, as an example, a great example of a float that is used in most programming is pi, 3.14. I think that's great. Now, you couldn't have something like, let me just space over here. You couldn't have something like 0.14. Okay, this is not considered a float. You have to have on the left-hand side of the decimal value at least some integer there. So, or at least a number there, I should say. We have a 0.14. That would become a float at this time. Okay, so just know the subtle differences here. I'm going to delete that. And all I want to show you for this floats video right now, we're going to get into math. We're going to get into looking at integers and strings and all kinds of other stuff later on. We just got to define everything first. So I just want to show you the different points of precision here. If we come in here and we just print these out, which we can, and all we're going to do is change this to an F this time. So max size in F32, F64, and we're going to do the same thing here. Just save this and then print this, or I should say run this. So if we just run this, okay, and you can see the different bits of precision here, F32 versus 64-bit here. All right, so we can go into later on the amount of precision and looking at the addition of two floats if we wanted to. You could take something like, I don't know, like a 3.14 and then whatever the digits are, and then just add that together and see the differences with the placeholder F32 versus F64. There's way more precision on the F64, again, because we have more bits there. But you can actually prove that by adding two floats together if you wanted to. We can cover that later on. So that's it for floats. We're going to go ahead and move on to the next scalar type. Okay, next up are Boolean expressions. So we can just type in Boolean, and the best way to think about these is true or false. And this will come into handy later. We're not going to really get into it too much. We just need to know that something can be true and something can be false, and that's a Boolean expression. They are represented by bool, B-O-O-L, and we have statements that we'll make that are conditional statements later on. If you've never taken a programming class before, that's okay. But if we have an if statement, for example, if something is true, then do this. Or if false, then do this. And that's really what Boolean's after. If something returns true, we might want to do something later on. Or if it returns false, we may have different conditional arguments based on true or false. So knowing Boolean is very important. And later on, we're going to get into what are called truth tables. So you might see something like different operators such as and or, and then we might say something like if something is true or false, then it might be true. Versus, we'll just say versus, where something has to be true and false, then it's false. And that might not make any sense right now, and that's okay. But we'll get into truth tables and why this can be important as well. So Boolean's great for conditional statements. It's great for truth tables. And we'll get on with that later in the course. I just wanted to introduce you to the idea of true or false, which is pretty straightforward at this point. So that is it. You can go ahead and delete this comment. We have one more scalar type to cover, and then we'll get on to more fun stuff in the course. Okay, the last scalar type is going to be a character. And this is actually defined as char. You can call that char or char or however you want to call it. And all we need to know is this is 4 bytes. So we saw the print line statement before, and I'm just going to type one out as an example. We don't have to actually write this, but we saw print line and we said, okay, well, I wanted to print something, and remember we tried to do like a string, like a bus, something like that. That doesn't work. But if you wanted to have a character of an A, as an example, you could print a character out, depending on what you're trying to do. So like A, for example, could be a grade. That could be a character. But characters also can be like emojis. They could be Unicode. It could be a lot of things, whatever you want to store within that 4 bytes. It doesn't have to be a letter, and it's not a string. So take it out of your mind that what we're looking at here is a string. A character is a 4-byte character. That's it. And it can be many different things. So I'm going to go ahead and delete this right now. Just know for now that characters are 4 bytes. They're represented by the char, and that's it. We're not going to really use these that much in this course, but it's still important to define these, so that's what we're doing. Outside of that, we're done with this video, so I'll go ahead and see you in the next one. Let's now talk about variables. And why do we call them variables? Well, because variables vary. And Rust handles variables a little bit differently than other programming languages, and we'll talk about the differences here in a second. But let's just do what we've been doing, but store it in a variable. So we're going to do hello world, but let's just declare a variable, and we're going to do that by saying let, and then we can just call the variable whatever we want. Here we'll just call it hello, and we'll say hello is equal to, we could put quotes here for a string, and then we'll just say hello world. And you can see that some things auto-populate. We have this declaration here of this ampersand str. Don't worry about that right now. We'll declare what these are later when we actually cover strings. For now, just know that there's some auto-population going on. And now we need to call this. So let's do a print line, and we're going to say, we're going to put quotes here. We're going to put these brackets, again, this placeholder here for what we're going to be calling, and we're going to be calling hello. So all we need to do is that. We can save this, and then we can run this, and it prints out hello world. Now, something interesting about variables, at least in Rust. Variables in Rust are immutable, and we can make a note here. variables are immutable, okay? In most programming languages, they are mutable, meaning that if we came in here and we just said, hello is now equal to hello again, and we printed this out, we would imagine that this works. In fact, it will not work, and I'll take a look at why. So if we do the same thing and we just print hello again, probably should have copied and pasted it, but we're too far into this now. All right, we saved this. You can see we've got an error already here because it's saying cannot assign twice to immutable variable. If we try to run this, it's going to give us an error. It's going to say exactly what it just told us, cannot assign twice to immutable variable. So immutable means it cannot change. And that's what we're seeing here. We cannot have this variable here be hello world and then change to hello again unless we declare it as mutable. And we can do that with mut. So now we could say, let the mutable variable of hello be hello world. And later on, we can declare it again, and now it's hello again. We save this, and then we run it. And you can see hello world, hello again. And variables don't have to be strings either. We just use strings because they're easy. But what if we wanted to take a number this time? So let's make a variable, and let's just call it x. And we'll set x equals to 5. And then we'll have y, and we'll just set y equal to 6. Why not? Okay. Here, what we can do is, say if we wanted to do math in Rust, and we're not going to get into math right this second, but just as an example, we can declare both of these here, right? And then we could say equals, and then you can have something like x, y, and then x plus y. If we declare here one more, and we save this, this should work. So let's take a look at this, run it. Okay, math and Rust. We got 5, 6 equals 11. And this probably should be like a plus sign or something, right? And then run that again. So math and Rust, 5 plus 6 is equal to 11. What are we doing here? We're declaring x as a number, an integer, and we're declaring y as an integer. And this is why learning the integers are important, because you can see what happens here. We auto-populated that signed integer at I32, so that 32-bit signed integer. Remember the defaults we talked about? This is, again, faster even on a 64-bit system. So we declare our variables, 5 and 6, we plug them in, and we can actually do math as well. We'll get into math operators and other operators later on in the course, but just letting you know that there are multiple ways to do variables. They don't just have to be strings. They could be lots of things that get stored within the variable. Okay, there's one other item to talk about, and those are constants. So let's do constants down here. And constants start with C-O-N-S-T, just like that. Okay, and there's a few different rules about constants. First of all, they have to be what's called scream case. So before we were doing like x, and we could say something like value x, something like that, right? Well, here we have to call them as scream case. We might say a number like that. Scream case just means all caps. So we can say constant number, and then we can give the number, I don't know, 17. But we need some other things in here. We actually have to declare this expression here, or we have to declare the annotation type. So you see how we have an annotation type here that was automatically triggered for us. We need to actually put that in here for this as well. So we've got our scream case, and this is an integer that we are giving it. So we're just going to give it an I32. And now this looks okay. So we have to declare in scream case, we have to declare the annotation, the type annotation here. And then we also have to make sure that we have a constant expression. So this is what looks good here. I'm going to go ahead and save that. And then we can actually just print out the constant. Let's just do a print line. And just make it simple. We'll give quotes and just print out number, just like that. We'll save this, run it. Okay, and you can see it prints 17. Now, why do we care about constants? Why aren't we just using let here? Well, constants can be placed outside of your function. So right now, everything we've been doing up until this point has been within a function. And we're in the function main. We can actually take this constant, just copy it, and I'm just going to delete this, delete a few lines, go above main here, and then paste this, save it, and if we run this, what's going to happen? It's still going to print 17. Okay, so we can place them outside of the function. They are global. This is a global variable. They are immutable, okay? Just like the other variables, they are immutable. And when it comes to compiling, constants are actually very fast. So there are benefits to using them. They're global, they're immutable, and they're fast. That's awesome. So depending on when we need a constant, we may have something that we want to set specifically, like a number or a value, and we put that in here, and we're going to keep that global. Awesome. So at this point, we've covered the 3 different types of variables. We have just standard old immutable variables with the let. We have mutable variables, which use the MUT, correct? And then we have constants as well. So make sure you understand the differences. Make sure you understand the rules of a constant, that we have to use the scream case. We have to define or declare the type annotation here, and that we are able to use them in a global fashion as opposed to our other variables that we have. So that's it for variables. We're going to go ahead and jump into scope and shadowing. So I'll see you over in the next videos. Let's talk about scope and shadowing. So we have a function main here. Let's declare a variable of x again, and we'll just declare this equals to 1. And within blocks of code, we have our scope. So this x is within this block of code here. We've got our curly braces, that's a block of code. In theory, we could have another block of code. We'll see this with if statements, conditional statements, other things, but we can have other variables declared within here. We can have like let y equals 2. Now, within this block of code, we can actually come in here and just print line and call out both x and y if we wanted to. We could just say something like, again, we could do math. Why don't we just do math? We'll say math, and we'll just do x plus y equals, okay? And then we'll just do this here. And we could say x plus y equals, we'll give a comma, and we'll just do x plus y. And the output should be 3. And if we save this, run it, okay, math x plus y equals 3. Now, what happens if we take this print line statement and we just come outside of this block of code, we paste this and we run this? What happens here? Well, I saved it and now I have an error. What's going on? Well, we have a local variable. Okay, well, what's happening is this y is living inside of this block of code. Because this y is inside of this block of code, it's only going to run within this block of code. This is not a global variable, it's local. So our scope is important here, where you can see we have a local variable to this function of x, and that runs fine. Now, if we took the y, for example, and we just moved it up, that would fix this code here. In theory, just do something like this, save it, and then that would be fine. And now you can see it prints the statement twice, which is what we're expecting. So understand scope. Scope within a block of code is all that happens. Remember, we have constants if we want variables to live outside of our functions, but we can also declare variables within a function or within a block of code, and where those variables live matters. So if you only want to use a variable for one instance or one statement, you can do that, and then once it gets out of the block of code, you'll never see it again, and that's awesome too. So you just have to understand when and why you're going to use variables in certain situations, and where their scope is local to or global to. Okay, let's talk about shadowing as well. So let's delete this y here, and we're just going to actually make a print statement of x. Let's just print out x. Okay, so I'm just deleting some things. All I want to do is print out x here. I'll delete this as well. So if x is equal to 1, and then we declare x here, set that to 2, and we copy this print statement and we put it down here, something like that, what do we think is going to happen? We've got the variable of x being 1, and then we say, no, x is 2, and then we're going to print out x, and then we're going to come back here and we're going to print x again. All right, so within this block of code, again, local, we have x representing the value of 2, which is what prints out. X then represents the value of 1 within this function outside of this block of code, and when we print that, we actually get the value of 1, which is what's expected. Go ahead and clear this out. Here's another example. if we have let x equals 1, we can actually declare something else. We can say like let x equals hello. And then if we print that out, just say print line and we print out x, what do we think is going to happen here? Let's go ahead and save this, run it. Okay, and we get a warning, our first warning, not an error, and we do get the hello printed out. So we actually have shadowing. So basically all shadowing is the ability for us to redeclare this variable of x within the same scope using the same name. Okay, so we had it as an integer before, then we changed it to a string, and that's perfectly fine. Let's go back to our example really quick. I do want to show you one thing. Again, we had that x equals to hello, and we got a warning there. Now, the warning is unused variable x. We have this variable that we're not actually using because we're declaring it and then we're redeclaring it. Well, it's telling us, hey, if this is intentional, you can just put an underscore here to fix the error. There's also one other way to fix this error, and we'll go ahead and just use that now. Now, I don't recommend this for coding. I think having the errors in for debugging, it's better to have this missing or to leave it as is, to have the warnings. But if you do want to get rid of your warnings, you can do a shebang here, a pound symbol and an exclamation mark. And then we just come in here and we say allow, and then we can just say unused. Just like that, okay? And this will stop the errors from happening. We save this. We run it, you can see it doesn't happen now. So we're allowing for unused variables here or unused items when we get into other items later on. So we'll just go ahead and leave this up here because we are going to start importing some stuff. But from here, just understand the difference between scope and shadowing. We've got scope. Again, scope is local to, or the variables can be local to their code blocks. And then we have shadowing, meaning that, hey, a variable can be changed. We can be redeclared using the same exact name as you see here. So that's the differences in scope and shadowing. We're going to go ahead and move on to the next video. Let's briefly talk suffixes and underscores in Rust. So suffixes are used to specify the type of a numeric, all right? A numeric literal. We could take a look at this really easily. So let's say, for example, we just say let x equal to 42. When we do that, we automatically get a signed integer of a 32-bit. But what if we didn't want a 32-bit integer? What if we wanted a unsigned 32-bit integer? Well, we can just come in here and put unsigned 32, a U32 right here, and it works just fine. Can prove this concept by just coming in here and saying something like this, and then just printing out x. And if we save this and run, you can see that we print out 42. Pretty easy. We can also use underscores in Rust. So we can come in here and put an underscore in here, and all it's doing is it's still reading the value, it's just giving separators here. Because reading 42 U32 is kind of hard on the eyes. But if we do 42 underscore U32, it's a little bit easier to read. We run this, we still get 42. So you could think of this almost as just kind of a spacer for human eyes. Another example is we could say let y equal 1,000,000. Okay, that's perfectly fine. It's still 1,000,000. And we can save this here and run this and we'll print out 1,000,000. And also, we can separate these. So what if we wanted to make this just look like this? It's no different, all right? It'll still print 1,000,000. This is much more readable on our eyes. We can't use commas here to designate 1,000,000, but if we wanted to use underscores, we could. So we can use underscores as spacing. We can use suffixes here as well. So again, we can do an unsigned 32, we can do an I32, and that will change. You can try doing a float. That'll change. You can see it just updating automatically, right? So we can specify here, if we wanted to, a number just using a suffix. Just wanted to show you this because it is used sometimes in Rust, and another way of declaring what type of integer or float or whatever it is that we want here. So that is it for this video. I'll go ahead and see you over in the next one. Welcome to your first challenge of this course. Now, this challenge will be also listed below this video, so if you scroll down on the video, you will find all of this text here as well. But I'm going to cover the challenge with you briefly. So in this challenge, what I want you to do is build a little program. And this program has a few requirements. The first thing is we need to have a constant integer, a global constant integer, with named birthday with a value of 1. Okay, and then we need to have a local string variable with my name, and you can set your name as the value. We need another local string variable named my birthday, and you can just set your birth month and day. You don't need the year as the value. Next, you're going to set up a local mutable integer variable named age with your current age as the value. You're going to then set up a local integer variable named new age with your age after your birthday as the value. So, big hint here, you should be using this 1 as an addition here somehow. We'll take a look how we do that in the challenge. But just think of what you've seen so far and how you might do that. And then once it's all said and done, you're going to print out my name is X. So you're going to replace that with your name. You're going to replace age with your age, and I am X years old. And I will turn whatever your new age is going to be on whatever your birthday is. Okay, so we'll do that. Go ahead and just stop here, think about it, code it out, and then go ahead and move to the next video where we'll walk through the challenge really quick. Okay, how do you think you did? Let's take a look at this challenge, and we're just going to tick things off as we go. So the first thing that we need to do is we need to set up a global constant integer named birthday with a value of 1. So for global, we're going to go ahead and be outside of our main function here. And when we do a constant, we just do const. And remember, we have to do screen case on this, so we have to say birthday in all caps. All right, and then we can set this equal to a type. We're going to give it an integer. Default integer is a signed I32. Okay, and then we're going to set this equal to 1. And that achieves the first step. So we want to have a constant birthday of 1. Go ahead and delete this. Next, we need to have a local string named my name with our name set as the value. Let's go ahead and just do that down here. So we're just going to say let my name equals Keith. Okay, and that's it. It'll auto-populate that string for us. And we've set that up. Next thing it wants is our birthday. So let's go ahead and set up my birthday. And then we're going to set that equal to another string. We're just going to go June 29th. All right, and then I'm going to delete this. Make sure we add our semicolon here at the end so it doesn't yell at us. Okay, we need a local mutable integer on this one. So let mute, and then we're going to name it age, and we're going to give it our age. So my age currently is 33, and then I'm going to hit enter on that, and go ahead and delete this line. Now we need to have a local integer variable named new age as well. So what is our new age going to be? So, well, what we can do is just set let new age equal, and we could just do our current age, right? We could just say age plus 1. We could say age plus birthday if we wanted to. Okay, we could also just say something like, we don't even have to have new age here. If you wanted to do this differently, you could actually just say age is equal to or plus equal to birthday. You could say age is plus equal to 1. But because we're going to call out the difference here, we're going to just go ahead and set a new variable. But we could set this as age plus birthday. All right. And then lastly, we just need to print out my name is X. And we'll do that here. So let's go ahead and print line. And we're just going to say my name is, and for every X, we can just do brackets. And I am X years old. Okay, and we could say I will turn X on X. And now we just got to fill in the blanks here. So we can say my name. We could say my age, or just age, I'm sorry. Then new age. And then lastly, my birthday. Okay. Make sure we close this off here with a semicolon. This is what it should look like. I'll give you a second to catch up. I'll also put this code under the video as well, just so you can have a solution to the problem. Say, we'll go ahead and save this now, and then we'll run it. Okay, my name is Heath, and I am 33 years old. I will turn 34 on June 29th. Go ahead and close that, and I'll just clean this up really quick so that I give you a nice, pretty code when we actually have it on the website. So that's what it should look like. And hopefully you were able to figure this out and you were able to understand the solution if not. And that's really it for this challenge. I just wanted you to get familiar with using constants, mutables, and just regular old variables and then putting them into print statements as we needed. So that is it for this video. I'll go ahead and see you in the next one. Okay, we've talked about scalar types when it comes to primitives. Now we're going to talk about compound types. And there are two types of compound types, and those are tuples and arrays. And we'll talk about the differences of what they are and what they look like. So let's start with tuples first. So a tuple can store multiple values of any type. So when we say store, we mean into a variable. So if we say something like let student A, and we're going to let student A equals, we'll give student A a name. I'm going to use my name. We're going to give student A a grade, and then we'll give student A a GPA as well. And then we'll close that off. And you can see that it already starts to build in and define for us. We've got a string here for Heath. We've got a character here for my grade. And we've got a float, 64 float, for 3.58 for my GPA. Now, we can actually call these stored variables here. So, as an example, if we said let, and we could just say let name of student A be equal to, and then we can call student A dot 0, just like that. So when we have indexes, we start with the number 0 is the best way to put this. So here is not item 1, this is item 0. This is item 1, this is item 2. So if we wanted to create variables for all of these, we could. We could say let grade of student A equal, and then we can just call this student A dot 1, and that'll pull the grade. And then we can say something like let GPA of student A equals student A dot 2. Okay, now we've got all those stored into variables. We can print something out that says, I don't know, let's just do print line, and we'll say something like, my name is this, my class grade is this, and then we'll have my overall GPA is this. Okay, and then we can just do a comma here, and then we can just call out our variables. So name of student A, grade student A, and then GPA of student A. And you should be auto-completing or be able to auto-complete these. Make sure you don't forget your semicolon there at the end. And then I'm going to go ahead and save this. If you need to pause to catch up, that's okay as well. And then we're just going to run this. So you can see it says, my name is Heath, my class grade is A, and my overall GPA is 3.58. Perfect. Did everything that we wanted it to do. Now, something to note about tuples is tuples can store a max amount of values. So max value of tuple is 12. So we can have up to 12 entries within a tuple. And one other way to group this is we could declare 3 variables at the same time. So let's actually just comment out these lines just to show you perhaps an easier way of doing this. We could say let, and then we could come in here and just say name of student A, grade of student A, and GPA of student A. And we could say let that equal student A. Okay, and that will store the values in here for us. So it'll say, okay, name of student A is index 0, grade is index 1, and GPA is index 2. We could save this and prove concept by just running this again, and you'll see it has the same results. So this is a way to trigger, instead of writing 3 lines of code, if you know they're all going to have placeholders, you can actually just put this into 1 line of code, and that's really nice. So that's it for tuples. We're going to talk about arrays really quick, and then we'll move on to the next section. Okay, I'm going to continue on with the same code. I just added a couple of line breaks here, and we're going to talk about arrays. Now, arrays are a little bit different than tuples. Arrays use brackets like this, where tuples, you can see, actually just use parentheses. So the brackets here indicate an array, and arrays can store up to 32 values. Where we had the tuples with 12 values, we can store up to 32. I'm going to write that in, store up to 32. And something to note is they have to be similar data types. Where you saw the tuple, we have different data types in here. With an array, we have to have similar data types. And the reason for arrays is because they are actually better at processing many values really quickly, provided all those values are the same data type. So let's take a look really quick at what an array looks like. So we could say something like let students, in this case, and we can have let students equal to all the same different data types, right? We could say like I've got a student named Heath, and then we've also got another one named Bob, we've got one named Linda, and so forth, okay? And those are our data types. Something to note here, and it auto-populated for us, but the way that we wrote it out was fine. But with the auto-population, we have a declaration here of what we have, our type indicator, which is a string, and then we have the amount of values that we're putting in here. So we have 3. So you can see it written either way. This is just auto-populated for us, which is nice. And then if we wanted to call things out, again, we could. So if we wanted to say, let's just print line, and we can do something like the first student in our array is, and then just give this. We could just say something like students dot 0. Sorry, not dot 0. 0 like that, okay? So note the dot notation here versus the bracket notation here, the difference between a tuple and an array. And then we're going to go ahead and close this off, save it, print it, hopefully, run it up here. Okay, and the first student in our array is Heath. We can easily just change that to a 1 to get Bob if we wanted to, run that again just to prove concept. Okay, the first student in our array is Bob. Not true, but that's okay. So that is the main difference here. Remember, tuples, they use parentheses, okay, and they store various data types up to 12, up to 12. Now arrays store data types that are similar up to 32, and they're a little bit faster at processing many values quickly. So make sure you understand those differences. That is it for this video, and that is it for this section, so I'll catch you over in the next one. Let's talk about slices really quick. So slices allow us to access a subset of elements within a collection. So a collection could be an array, for example, without having to create a new collection. That might not make any sense. Let's take a look at some examples here. So if we let an array, for example, and we could just let our array equal 1, 2, 3, 4, 5, okay? And in this array, we just want to grab the numbers 2 and 3, or the items 2 and 3, or the elements 2 and 3. All right, we come in here, we could say something like let slice equal to, and then we can call the array. So we can say at ARR, just like this. Okay, and then if we do 1 through 3, that should give us items 2 and 3 here. Okay, so what do I mean by this? We're not calling 0, so we're not calling 1. we're calling out 2. All right, so we're calling out item 1, which is item 1 here. We're also calling out item 2. We're not getting item 3 here, right? So with item 3, we'd actually have to put in item 4. Hopefully that makes sense. We're only grabbing the first item listed here, or the first element listed here, and then we're ending at 1 before. So we're technically only grabbing 2 elements here. Let's take a look at that. Hopefully that'll make more sense. So if we do print line, and then we just come in here and we say something like this, and then we just print out slice. Let's take a look at what that looks like. Okay, and we're gonna have an issue here. And this is the first time we've actually come across this so far in the course, but we can actually use what is called a debug format, all right? So if we come in here and we put a colon and a question mark, and we save this, then we can actually print this out. And this will allow us to print out everything within this array, or this slice of this array here. So you can see that we grabbed items 2 and 3. Let's say we wanted to grab item 4 and 5. What will we do there? Well, we would go, okay, we know 0, 1, 2. Okay, so first number would be 3. So we count 3. And then if we said 3 to 4, it would not grab 5. We'd have to do 3 to 5. We save that and we run it. You can see we now grab 4 and 5. Hopefully that makes sense there with the slicing. We can also use this to modify if we want to. So for example, let's go ahead and take a look at this. Let's change this back to 1 and 3. And let's say we wanted to modify an element here, but in a different way. What if we wanted to modify subsets of an element? So we have slice here, but we can actually take slice and we can grab an item within it, and then we can make that equal to something else. So if we made it equal to like 6, we can grab slice item 1 here and make that equal to 7. Okay. And then we can change these elements around. So now if we printed out something like debug mode again, just like this, and we came in here and we just said array like this, we might throw an error here, and we do. First of all, print line, save. Okay, we have an error here, and that's because we actually didn't call a mutable of this array here. So we need to make this mutable. Okay, we need to call the mutable of the array here. Okay, and then we save. Now we're mutable, this should print out. And what do we think this is gonna print? 1, 6, 7, 4, 5. So this is another way to change an element within an array. We can actually modify the slice, which then modifies this array. Okay, so that is really it for this concept in this video. I just want you to know that you can pull slices of an array. You don't have to call this the whole array. You can pull out certain elements from the array, and those are called a slice. So that's all you need to know for right now. And with that, we're going to go ahead and move on to the next video. Okay, let's talk about strings. So let's go ahead and just make a note in here. We got strings, and for strings, there are actually several types. We can just put that. There are several types, but we'll likely only ever use 2. So we'll just put likely only use 2, and those 2 are going to be the string, which is capitalized with an S here. Make sure you note that. And this string here, this str, which you're more likely going to see listed as ampersand right here, str. So let's talk about the differences between the two really quick. We can even make another line of notes here. Okay, so an str is what's called a string slice. And when we see at or ampersand str, that's what's known as a borrowed string slice. Okay, and with this, we have data in this borrowed string slice, and the data in the borrowed string slice cannot be modified. Okay. However, when we have a string, this data can be modified. And we'll take a look at what that means here in just a second. Another thing to note is that borrowed string slices are they're essentially a subset of a string. So essentially a subset of a string. And that's because these string slices, or these borrowed string slices, they consist of a pointer and some bytes and some length, where a string consists of all of those things plus capacity. So when we're looking at this, we actually have a string slice within a string. So strings are a little bit broader. Strings have capacity. Strings also allow for modification. So depending on what we're going to use throughout the course will then depend on what type of string we use. So for example, if we have something more static, like a greeting, like if we just say let greeting equals hello there, and we know that's not going to change, then that automatically becomes a borrowed string slice. Okay, so something to think about. Before we get into this, let's prove concept really quick. So if we have our function of main here and we wanted to have a mutable string, we'll just call let mute name equal Heath. Okay, and that's automatically going to convert over to that borrowed string slice. We come in here, we can attempt to do a push of a string. So we haven't gotten into methods really, but we'll talk about methods here really quick. So we could run a method of push string and we could try to push this, and we can just say space test. And what I'm trying to do here is I'm just trying to print out or add to the end of this. This is what a push does, is I'm trying to add to the end of this string a space and test. So that way when I print this out, I get Heath space test. Pretty straightforward. We'll come in here and just put in our brackets and we'll call name. And so a method here is similar to a built-in function. That's kind of what I like to think about it. Similar to a macro almost, but specifically for what we're running here. So this string will have its own method, and the method that we're trying to run is a push. And there are tons and tons and tons of methods. It's almost impossible to cover them all, but you learn them as you go, and we'll play around with some methods as we go through this course as well. This is just the first time seeing it. So with this method here, it's supposed to push again, so meaning it's going to put it at the end of our string. So let's go ahead and run this. It's going to trigger an error. You already see it lights up red. Run it. And it's going to say method not found in @str. So that's because we cannot actually modify this version of a string. Because why? Borrowed string slices cannot be modified. So what can we do? Well, there's a couple of different ways we can do this. Let's introduce ways to create strings really quick. So I'm going to show you this here, and then we'll create this string. So if we let our name equal to, and then we say string like this, and then say new, like that, that'll automatically create a string for us. Okay, and you can see it creates a string. Now, you saw this updated as well. Why? Because this method exists now. So it even tells you, hey, appends a given string slice onto the end of this string. Perfect. Even gives you some examples. I love IDEs. Okay, so we have that. Perfect. If we run this now, what's going to happen? It's just going to give us a space test. So we can either do two pushes, because a push looks like this, right? A push just appends to the end. So if we say name and then we just do a push again on the string, and we give it our string here of Heath, could do that, and then just save that, and then it'll push twice to this string because it's mutable, so we can continue to change it. So if we run that again, now it says Heath test. We could have also saved a line, just put Heath test in here, but maybe we're keeping this blank for something. Maybe we're getting input, which we haven't gotten to yet, but we will soon. So that's one way to look at this. So I'm going to give you a couple other ways to create a string really quick. We're not going to really play with this too much, but I just wanted to show you this. So you saw us define a variable here, just mutable string, and then we just said, hey, it's going to be a string. We didn't give it any value, any data inside, and that's okay. Now, if we wanted to create a string, we could do that in other ways, and we can provide data. Like we could say let name equal to, and then we could say Heath, and then we can use a method here and just say to string like this. Okay, and that will convert it to a string. And you can see that the borrowed string slice went away. We can also do let name equals, and then we can give it string like we did before. And instead of saying new, we can just say from, and we can say Heath, and that will also create a string, okay? So there are several ways to do this. You can create the string as we did before, where we just store no value within it and then give it a value later on through different methods. We can define what the value is automatically and then convert that to a string. And we can use this in several ways. So you've seen many different ways to create strings. Really, the big takeaway from this: understand the difference between a borrowed string slice and a string, okay? Again, difference is cannot be modified versus can be modified. And this is essentially, again, a subset of a string because strings have capacity. So keep that in mind as well. We'll play more with strings as we go through the course, but right now this is just the quick and dirty overview of what strings are. So that's it for this video. I'll go ahead and see you in the next one. Let's briefly talk about character escaping. And what do we mean with that? Well, let's go back to the old print line of hello world. And we'll just say hello world, just like this. And that's fine. We know this, right? Well, what if we wanted to make this into multiple lines? We could do that. We could say print ln. We can come in here and just say hello world. And what if we just like went in here and just hit enter? What would happen if we did that? Okay, let's save that and run. Okay, so we've got hello, and then it does break a line in here automatically and put a world in here. What if we wanted this to be all in the same line, but we just wanted to print this string for more readability? Maybe this is a paragraph or something we're printing out. We don't want it to run all on line 5. We want it to run down the page so that we as a human can read it. Well, we could add something like this, okay? And just save it. So the backslash, and then look what happens. With the backslash, we terminate that, or we escape that, and now we have hello world. Another way to think about this character escaping would be, what if you were doing a quote, for example? Like, he said, and then all is fair in love and war. Something like this, right? And we just did quotes like this. You could see that we've got some color issues already happening here. That's a good indicator, is the color, right? But we can see, okay, well, this string ends here, and then we have all this weird stuff, and then we don't start another string until we get right here. So all this in between is just kind of weird. Let's go ahead and just save this. You can see it's red. We try to run it. It's going to yell at us all different types of places. What can we do here? Well, we can do escaping. Same concept. If we escape this, okay, now we have this built in, and then we can also escape right here, and that should fix everything. Let's save this. Now everything's green. Let's run it. And you can see he said all is fair in love and war, and the quotes actually stay because we escaped that quotation there. So escaping is important depending on what you're doing with it. We can also concatenate strings. So it's a little bit easier in Python, but there's actually a method built into Rust. So if we come in here and we just say something like quotes, and if we wanted to say something like hello world, we could. You can imagine at this point that we have 2 variables stored, but I'm just going to use 2 strings really quick just for the simplicity of it. So here's our method concat, and if we hover over, it'll tell you what concat does. Concatenates literals into a static string slice. Awesome. Okay, so if we're concatenating here, we can come in and we can just say something like hello, and then add another comma, world. And you can make these variables again that are storing strings, but we're just going to close that off, and this should print, hopefully, hello world for us. Okay, spaces would be nice, maybe lowercase, maybe exclamation real quick, just to make it look the same. Okay, hello world, and then a comma as well would be what the rest of these have. So that is really it. I just wanted to teach you briefly escaping. I wanted to show you that you can actually store macros within a print statement or in other statements, as we'll learn. I'm just trying to introduce little concepts to you. Just same thing as like we did with the methods last time. I don't want it to be one big lecture of a gotcha when we get there. So just starting to understand that there are other macros out there, there are methods out there, there are ways to do certain things, and we're just continuing to build upon those as we go through the course. So baby steps, it'll get a little bit more complex as we go. That's it for this video, and that's it for this section. So I'll see you over in the next one. So we're going to talk about user input next. Before we do that, we actually have to use a library. And that library is the standard IO or input-output library. And if we go to the main Rust webpage, we actually scroll down, we look at the documentation, we can come to the standard library here, which is the comprehensive guide to the Rust standard library APIs. Very nice. The documentation is fantastic. So we have STD, which stands for standard. And we look at libraries here. If we scroll down and we look for the IO module here. So if we come to IO and it says traits, helpers, and type definitions for core IO functionality, this is what we're going to be using. I'm showing you this because if you ever have questions on why we're doing something or what we're doing and you want more information, again, documentation is fantastic. We can come here and look at this module, standard input output. You can see what it says. Okay, hey, what is this? Well, this is everything you'll need for doing input and output, including read and write, and then it gives you examples. So it starts with read and write because that's the most common, but it has other examples within here, and you can actually scroll down and see all the fun stuff that it can do and the documentation included with it. For now, we are doing input, right? We're going to take some input, user input, and we're going to need this functionality. So we're going to import this. And that's why I'm showing you this. Let's go ahead and cut over to our Visual Studio. Okay, and when we want to import here, we're going to just come in here and say use std and then IO, just like this. And congratulations, we have imported this. So if we look at this, now we don't have anything going on. We would get an error if we weren't using this allow unused, because in theory we haven't actually used this yet, but this is why we have this allow unused up here for our purposes. But this allows us to now accept user input. So we'll stop here and we'll go ahead and talk about user input in the next video. I just wanted to show you that we can import libraries and that there is documentation behind those libraries, and reading documentation, Googling, spending a lot of time outside of code is going to make you a better developer, better coder, etc. It's all about troubleshooting. So I'll see you over in the next video. User input. What is user input? Well, user input means that we can take input from the user. Sounds simple, right? Well, we can ask the user a question, have them type something in, and then we can utilize what they type in our code. So let's take a look at that in a very, very basic sense. So let's build a little program here, and we're just going to give a print line, and we're just going to say, who goes there? And once that prints out, we're going to go ahead and create a string. We'll just call this name. We want it to be mutable, so let mute name equals, and then we learned that fancy trick of creating a string, right? So we'll just say new, just like that. And then we want to read input, or we want to take input. So what we need to do is do IO, because we imported it, right? And we're going to say standard in, just like this. And then we're going to read line. This is what it looks like. And then we're going to call the mutable that we have here, name. So what's going to happen is we have name, which we're storing, we're creating a string, brand new, nothing inside of it. And then we're going to take input, we're going to read the line, and then we're going to put that into our mutable of name. Pretty straightforward. And then we could just say something else. We could even just show this first. Let's just save this. So if we run this, it says who goes there, just say Heath, and it'll close the program. There's nothing, there's no end or anything here, right? So that's step one, that's good. So now we can come in here and we can just say let enter equals you may now enter. We don't really have anything fancy yet, like we haven't given any sort of, I don't know, like conditional statements. We haven't learned conditional statements yet, so we can't say if name is Heath, then you can enter. If name something else, then you can't. But for now, we'll just pretend that Heath is allowed to enter, and we can come in here and just do a print line. We could say something along the lines of, hello there, and I don't know, we'll just give it this. And then we can give a greeting as well. So we can enter the greeting. And we could do something like name and enter, for example. I just want to show you something here. Let's go ahead and print this out and run it. See what this looks like. Okay, so who goes there? Heath. And it says, hello there, Heath. You may now enter. Well, we had a line break here, and automatically we have a line break on the end of our string. So we can actually just come in here on name and add a method. And this method is going to be trim end, and that's going to trim off the last bit, which is going to be that that break line here. So it says returns the string slice with trailing white space removed. So any white space that's going to be there gets removed. We're going to go ahead and save this, run it one more time. And who goes there? Heath. You may now enter. Perfect. That looks great. So that's it. I just wanted you to understand the basics of importing modules and libraries, and also the basics of user input. We'll play around with user input a little bit in our challenge, our next challenge. For now, we're going to move on to learning math and operators in Rust. So I'll see you over in the next section. Now let's talk math in Rust. So math is built into Rust automatically, and we'll take a look at what that looks like. So let's define a couple of numbers really quick, and we're just going to say let x equals, let's call it 10, and then we'll let y equal to 3. You can pick whatever numbers you want. I'm picking two numbers that are not divisible by each other, at least not purely divisible by each other. So 10 doesn't have, or 3 has a remainder when it goes into 10. And we'll show you why we're doing that here in just a second. So what I want you to do is do print line, and we can just say something like this placeholder plus placeholder equals placeholder. Okay. And then you can just do something along the lines of x, y, and then x plus y. And then we'll space this out, just make it a little bit cleaner. And that should, in theory, print out our answer. So let's save this, run it. Okay, 10 plus 3 is equal to 13. So we've seen this before, kind of. We are now looking at it with using variables as placeholders. And we're just going to copy this line and change the math around a little bit. So I'm just going to do like 4 more lines in here. And we can just do a minus. We come in here and do a minus. Can do an asterisk for multiplication. Do that here. And then we'll just do division as well. So come in here and do division, and we'll save this, run this again. And now we've got our math and everything looks correct, except this one right here just gives us 3. But it tells you how many times it goes in, doesn't tell you the decimals or anything else. Why might that be? Well, because we're using integers and not floats. So we can convert these to floats really quick if we want to. So we could say let x float equals to x, and then we just say as f64 as an example. And that will turn this variable into a float, or it will turn this into a float and then store it into this variable, I should say. And then we can do the same thing with y and say let y float equal to y as f64. And now those are both floats. So we can come in here and store. We don't even have to change x and y in our equation, right? We can just come in here and just say x float for this one, and then float for this one. And that should work. So let's go ahead and save that, run it. And there you go. Now we get that it's 3.33333 forever with the round up to 5. So we can also see the remainder here. So if we take one more line, let's just copy this line here, just paste this. And what we'll see is we can get a remainder with a percentage sign instead. So, and this is called, everybody makes fun of me when I say it, a modulo, I don't know what you call it. Never really learned the official answer. This is what happens when you don't go to college directly for computer science and you're self-taught. So in here, we have this, and this will give us a remainder instead. So if we save this and we actually run it again, you'll see that we get an answer of 1. That's the remainder. Okay, so it's nice if we ever need a remainder, what's left over. That's the way to do it, is with the percentage sign. We can also take to a power. So let's copy another one of these lines, and we're actually going to have to use some built-in tooling here. We can't just give it the caret like this, although I wish we could, but we can come in here and maybe clean this up, make it look like this. And then we could take X, Y, and then we need to take this to a power. So what we can do is we can come in here and do something like I32. You could use I64 if you wanted, and you can come in here and just say power, POW. And then we can come in here and say, what do we want the power to be? Well, X to the power of Y is what we're trying to go for. All right, and then we can just save that and then try running it. You see we have an error here, and the error is saying that it's expecting a unsigned integer and it found a signed integer. So we can convert this if we want to. We can actually try what it's telling us here with to try into unwrap and see if that works. Let's try this out. Let's just do a little bit of error troubleshooting here. And we do this, save it, see if it actually works for us. Run it, and we get 1,000. 10 times 10 is 100, times 10 is 1,000. Now, as a default, what we just did is not recommended, but it did work. If you actually read into this, it says, hey, what are we doing? Well, we're taking Y and we're converting Y, okay? And then we're taking unwrap, and it's returning the value of okay when consuming the self value. And it's saying, hey, this can cause a panic, this can cause issues, not recommended. So just something we tried due to our error handling. The appropriate way to do this would be to give it the U32 that I was expecting and letting it run. But here it does work, just showing you to read your output and then also read what you're doing. Don't just copy and paste like we did, and actually make sure you understand what is the best method moving forward. So this would not be the best method, even though it did convert it to a U32 for us. So that's it for basic operators. Let's pause here, keep your code, and I'll meet you over in the next video. One more thing I wanted to show you was importing modules or libraries and then having dependencies with them. So we're going to be importing something called rand, which is going to be a random number generator. And we can come in here and we can say use rand like this, RNG, and it has no idea what we're talking about at this point. So if we save this, it's going to give us an error because it doesn't know where it is. It just says unresolved import rand. Okay, well, we need to actually declare this, and this is where this TOML file comes into play. For now, let's just go ahead and type in rand is equal to 0.8.5 like this, and we'll save it. And then we'll come back and we'll save in here and try to run this. And you can see now, actually, without even running it, that this has been resolved. There's no error anymore. That's great. So what the heck just happened? What is rand? Where are we finding all this stuff? Let's take a quick look out on the internet. So a great website for finding out information about what are called crates or packages or libraries or dependencies is going to be crates.io. This is the website name right here. If you just go to crates.io, for example, if we're looking for rand, we can come in here and just type in rand and hit enter, and it will give us the information that we need. Here is rand. It's on version 0.8.5. That is the dependency that we had to put in to our TOML file in order for this to work. So you can see when we click on this, it says, hey, random number generators and other randomness functionality. Perfect. So this is a Rust library for random number generation, and it tells you all the different things that it can do. It talks about the usage, talks about putting it in for the dependencies. Again, documentation is everything. If you become a developer, a lot of your time is going to be spent reading, as much so, if not more, than actually developing and coding. So you come in here, you read and understand what it's doing, how you would add it if you need to. Cargo add rand would be the command. We don't need to do that already, but we can import it with rand is equal to 0.8.5, which is exactly what we did. So if we come back here, you can see rand is equal to 0.8.5. We've got it imported correctly. We have called the library in here, and now we just need to use it. And I just wanted to show you this. We don't need to demonstrate it. There's no necessary purpose for using rand, but this is a great way to show dependencies in Rust. So if we come in here and we actually look at this random number generator, what we can do is we can define a random number in here. So we can say let x, instead of being 10, we can just say let x be equal to a random number. So we can just say rand, and we can give it thread range, like it's asking for. And then in here, we need to give it the range of randomness that it can have. So if we say gen range, and it's going to ask us what the range is. So if we wanted to go 0 to 100 or 1 to 100, I'm sorry, we can go 1 to 101. Okay, and that will pick any number between 1 and 100. Okay, 101 is not included in that. Now we can come in here and close that off and save this. And then now we'll get random numbers for x. If we run this, okay, and we can see that it shows 32 as the random number for us. And we use 32 in this equation, and this is what happened. We can try running it again, and it will give us another number. Here we got 81, and it gave us random numbers here. So, interesting, fun, something to think about. But this is just an example of using a library, importing it, knowing the dependencies, how to find them on crates.io, and then actually utilizing them in our code. That's all I want to show you for this one. We're going to go ahead and stop here, end this section, and we'll see you over in the challenge video. All right, it's time for your second challenge, and this is going to be another easy challenge that we're actually going to build upon later on in the course. So what I want you to do is to make a simple calculator. So we kind of showed this already, but I want you to expand upon it just a little bit further. So I want you to take two inputs, all right, two user inputs, and then calculate the addition, subtraction, multiplication, and division of those two inputs. Now for division, make sure that you are taking that and making it a float, just as a little tip, but for the rest, they can just be basic integers. So go ahead, type this out, figure it out. Once you got it done, meet me in the next video. We'll just do a quick walkthrough on what the solution could look like. Okay, were you able to figure it out? So this one was intentionally vague. I wanted you to be able to go out and Google and look for a solution because that's what we have to do as programmers. So we have to take two inputs, and we've looked a little bit at taking inputs, but we took inputs as strings. We didn't actually take them as integers. So how do we do that? And then how can we utilize that in this process? So let's take a look at that. So first and foremost, we want to have two integers. So let's first just print a line, and let's just say something like, give me a value for x. Okay, and that'll print out, give me a value for x. Perfect. Now we need to define what that might be. So we can say let mute, and we could just call this input of x, and then we could just say string new. So far, this is all familiar to you, familiar information. Okay, so we've got the input of a string, and then we can still take that input of that string. So we can do the IO, we can do the standard input like we have before, and we could read a line, and then just take that at mute of input x. Okay, if my tab will work, there we go. So we've got this so far. Now we need to convert this to a number. This is where your Google foo should come into play, and you can figure out a little bit of information. This is where we learn some of these methods and other tools that are attached to these sorts of items. So we can now define a variable. Let's just say let x, and we can let x equals I32 for this. We do have to define here, unless we define in the parse, which I'll show you here in a second. So we can say let x equals I32 of input x, but we have to trim this, meaning we have to take out the white spaces, because what happens before we do anything further, what happens if somebody enters in like space, space, 5, space, 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 it's going to try to take all that and it won't be able to read it. So you got to trim the data around, or the values around what's there. So we're trimming all the white space. Next, we need to actually parse this into what we're giving it. So we're parsing into this I32. We can actually hover over this parse and see what that looks like. So if you scroll down on some examples, we're giving it a I32 right here, and we're parsing. Here you can see another example where we can actually parse and then give the value of the I32 on this side of the house. So either side of the equal sign you can utilize. I just prefer utilizing the left side. One more thing we do have to do here is we have to add an exception. And to add an exception, we actually put expect instead of accept. I've never really understood that, but to each their own. And we could just say something like entry was not an integer. Something along those lines, right? And then we can give an exclamation if we want, and then just go ahead and close that off. And that should take this for us. So what we can do is we can come in here, we can print line, and we can just say something like the result of, and this is just a test, just to make sure we're good. I'm going to give it 5. The number we entered in 5 is 5. Okay, so oops, is that, and then we'll just say, we'll give it x, and then we'll just give it x times 5. So we should be able to enter a value here. Let's save this. Enter a value. It should be able to parse this down and then do the math for us. Let's take a look at this. So it says, give me a value for x. We'll give it 3. Okay, the result of 3 times 5 is 15. Perfect. Now let's look at this expect really quick, because this is the first time we've actually seen this, and using these are really awesome. That's the nice thing about Rust, is that exceptions are built in, and we can utilize this. Let's take a look to throw an error. So let's say if I give a non-integer, like I give L. See, L didn't work because we were expecting an integer, and it says right here, entry was non-integer. So we had a parse error, and that's perfect. That's what we wanted to have happen there. So we're even controlling some of this. If we're not getting a number value in here, it's going to cause an error in the program. That's awesome. Okay, so we need 2 inputs, right? So not just one. So let's go ahead and make a new line here. And I'm just going to copy all of this. And we're just going to paste that, make life simple for us. And we're going to say, give me a value for y. And instead of input x, we're going to call this input y. And then we're going to call this input y. And then we're going to call this input y. All right, and now all we have to do is just make this x, y, and then x times y. Hopefully that makes sense. We're just replacing values here. And now we should be able to give 2 values and have that multiply on its own. So let's save this. I made a mistake. Hopefully you caught that. Saving it through the red error for me, and I see that now. Let's save that. Okay, so now we have to declare let y equals input y. Okay, now let's run this. Okay, give a value for x. I'm just going to give 4. And then this one I'll give 3. Result of 4 times 3 is 12. Perfect. Okay, so we're starting to build out our calculator. Very nice. Let's go ahead and complete the rest of the mission here. Right, so we needed addition, we needed subtraction, we said multiplication and division. Okay, those are the ones that we need here. So we're going to just change these signs really quick. We're going to give this a plus, this a plus. We're going to give this a minus, this a minus. We can keep the multiplication, and then we're just going to have a division in here. And we'll save this. Run this. I'm just going to give this 4 and 3 again. Okay, so 4 plus 3 is 7, 4 minus 3 is 1, 4 times 3 is 12, and 4 divided by 3 is 1 with a remainder. So we're missing the last step. We need to have our floats added into this. So what we can do here is we can just come in and we can just say let float of x equals x as f64. We've seen that before. Same thing here. We can just say let float of y equal 2y as f64. And then instead of using x, we use the float of x. And instead of using y, we use the float of y. Let's go ahead and save this, run it, and take a quick look here. So we're going to give a value of 5, give a value of 9, and then now you can see, okay, 5 plus 9 is 14, 5 minus 9 is negative 4, 5 times 9 is 45, And then for 5 divided by 9, we get 0.5555 forever until we get 6. So that makes sense. So hopefully that all made sense. As always, I'll put this solution for you in the description below the video, so you should be able to see that. Take note. And again, this was just a challenge for you to think outside the box and go and find an answer. Hopefully you're able to find that on your own. And we'll do more of that as we go. We're going to actually build a more intuitive calculator later on in the course once we start learning about conditional statements, matches, etc. So that's it for this video. I'll go ahead and see you in the next one. All right, we've reached the end of this course. Hopefully you found it valuable. Hopefully you are interested in learning more about Rust. If you liked the video, you made it this far, please consider liking, subscribing to the channel. We're pushing close to 1 million subscribers and would be grateful to have you here. If you really enjoyed this and you want to continue on, please do check out TCM Security Academy. Again, I'll link it in the description below, and you can check out the Rust course plus all the other stuff that we have over there. We've got over 20 plus courses over at the Academy. So that is it for now. My name is Heath Adams, aka the Cyber Mentor, and I do thank you for joining me. Peace out.